All right, welcome everyone to the first Physics for a lecture video. So the first subject that we will cover is called kinematics, and kinematics is just the study of motion. So the goal for this part is for us to mathematically describe the position, velocity, and acceleration of an object. So to do that, we need to define those variables in precise physics terms. So we'll start with position, and position is basically what it sounds like. It's the location of an object, but it's the location with respect to some origin. That is, we need to decide what location has a position of 0 before we can determine the position at other locations. And so the variable that's used for position, there's actually a few different ones, but if you're talking about the position in general, the variable is usually r, lowercase r. But if you're talking about the position along an x-axis or y-axis or so on, then often that variable is used. So the position could be x or y or z in 3 dimensions. And the SI unit, basically the standard unit that we use in physics, is meters for position. Okay, so next is velocity. And velocity is simply the rate of change of the position. And that's similar to what you would kind of think of as velocity. You might think of velocity as the same thing as speed, but it's a little bit different. It's both how fast something is moving and what direction it's moving in. So not just the speed, but also what direction it's moving in. And the variable for velocity is lowercase v, and the SI unit is meters per second. And then finally we have acceleration, and acceleration is just the rate of change of the velocity. And the variable there is lowercase a, and the SI unit is meters per second squared. So mathematically, we can already come up with a relationship based on the definitions of these variables. So for example, that means, since I said that the velocity is the rate of change of the position, that means that the velocity is equal to the derivative of the position, the time derivative specifically. So v is equal to dx dt. And similarly, the acceleration is the rate of change of velocity, so the acceleration is the derivative of the velocity. A is equal to dv dt. And then we can also work the math backwards, and since we use derivatives here, we can use integrals to go the other way around. So the position x is equal to the integral of v dt, and the velocity is equal to the integral of a dt.